Since we have learned how to add, subtract, and multiply polynomials, it should come as no surprise that we are now going to look at division of polynomials, and today we will look at long division of polynomials. Now this is very similar to long division of regular numbers, so I'm going to start with an example of that. Here we would like to divide 12 into the number 2,549, and we're going to do that by saying, okay, 12 doesn't go into 2, but it does go into 25 twice. And 2 times 12 is 24. So we subtract 24 from 25, we get 1, we bring down the 1. How many times is 12, we bring down the 4 and say how many times is 12 going to 14. It goes in once, and 1 times 12 is 12. Subtract 12 from 14, we get 2. And bring down the 9. How many times is 12 going to 29? It goes in twice. 2 times 12 is 24. So we subtract and we get 5, so that's a remainder of 5. And remember that this means that the question was, what is 2,549 divided by 12? The answer is 212 and 5/12. So that remainder is basically saying 5 has yet to be divided by 12. We're going to do a very similar process for dividing polynomials. So here we would like to divide x plus 2 into 2x squared plus 7x plus 7. And what we're going to do is we're going to look at the leading term in both our divisor and our dividend, and I'll say, what do I need to multiply x by in order to get to 2x squared? And the answer to that question is I multiply by 2x. And the way this is going to work is I'm going to say, okay, then 2x times x is 2x squared. 2x times 2 is 4x, and I'm going to subtract this entire quantity. And 2x squared minus 2x squared, and that should be a squared there, is 0. And 7x minus 4x is 3x. Okay, now I'm going to bring down my plus 7. And now I need to say, what do I multiply by x by in order to get to 3x? And the answer is I multiply by 3. Now I can look and say, okay, 3 times x is 3x, and 3 times 2 is 6. And I'm going to subtract the whole quantity. 3x minus 3x is 0, 7 minus 6 is 1, so I get a remainder of 1. This means that if I ask the question, 2x squared plus 7x plus 7 divided by x plus 2, well, this is equal to 2x plus 3 plus 1 over x plus 2, where this 2x plus 3 is right here, and my remainder of 1 is still left to be divided by the divisor here. Now, if you do all of the work up here in this red box, that's great, you've done all the hard work. But you've not given me your answer until you've written it out like this. That in the red box down at the bottom is the answer that we're looking for. Now, if this long division of polynomials came at you a little quick, that's fine, because we're going to do several more examples. Okay, now here I'm looking at another polynomial long division problem. This one's not too much more difficult. The only difficulty here is that my divisor no longer has a leading coefficient of 1. And really, that's no big deal at all. So we're going to start by asking ourselves, what do I need to multiply 3x by in order to get to 15x squared? The answer is I'm multiplying by 5x. And 5x times 3x is 15x squared. And 5x times 1 is 5x. And I'm going to subtract. Now notice I put parentheses around what I'm subtracting every time. If you don't, you are going to screw this up. So please use those parentheses every time. 15x squared minus 15x squared is 0, and 8x minus 5x is 3x. And I bring down my minus 12. And now I'm going to ask, okay, what do I need to multiply my 3x by to get to 3x? That's easy, 1. And 1 times 3x is 3x. 1 times 1 is 1. And I'll put it in parentheses and subtract. 3x minus 3x is 0. 12 minus 1 is negative 13. So I've got a remainder of negative 13, which means that the answer to the question, 15x squared plus 8x minus 12, divided by 3x plus 1 is 5x plus 1 minus 13 over 3x plus 1, or if you prefer, plus negative 13x over 3x plus 1. Now here I'm going to introduce a final polynomial long division problem with a little bit of a twist. The problem that I've got here is that this dividend, first of all, is not in standard form. So I'll start by writing it out in standard form, as this is 3x cubed plus 4x squared plus 10. Notice I left a big gap there. That's because when we're doing polynomial division, if we're missing a term when we write it out in standard form, we need to do something about that. So we're missing a linear term, so I'm going to put in there plus 0x plus 10. And that's really crucial for this long division problem, and it's divided by x minus 2. Now I can write this out. So now I've got the division problem written out, and I'm going to go through this fairly quickly. X times what is 3x cubed? Well, 3x squared. 3x squared times x is 3x cubed. And minus 6x squared. Subtract and get 10x squared, bringing down my 0x. And x times 10x is 10x squared. So we get 10x squared minus 20x, and subtract and get 20x, bring down my plus 10, and x times 20 is going to give me 20x, so I'll get 20x minus 40, and subtract is going to give me a remainder of 50. So my solution then, if I were to write out my solution, is 3x squared plus 10x plus 20 plus 50 over x minus 2. And there's my solution to this somewhat more complicated long division problem. So here we have 3 problems I would like you to prepare for class tomorrow. Problem 1 should be very straightforward. Problem 2 just has the added twist that the leading coefficient in the divisor is not 1. And in problem number 3, the twist is that there's something missing right here. And if you want to remember how to deal with that, just look back at our most recent example. So please prepare these for class, and I will see you tomorrow.